Hey everybody, welcome to AtCoder. I'm a bit new to this platform, so let's see how it goes. Today we have beginner contest 187. Let me show you. Yep. So we'll have 100 minutes for 6 problems. I've checked out the problems from the previous contest. I think they're not particularly difficult, but let's see how it goes. I think we have enough time for explanations, so I'll do this as well. You can see I already pre-written some templates, and that's pretty much everything we have to know. Let's go. Okay, simple implementation. So we are given 2 numbers, and we asked which has bigger sum of digits. I guess we can just implement it like this. Let's give it a quick check. We should get like 9. Hello. Hello. Why is it so slow though? Okay. Should get 17 and 27. Wait. Here is 27 and here is 17. You know what? I'm thinking I need a local compiler because this thing is clearly slow. Okay, I feel like we can submit. I think we can read the next problem while we were writing. Okay, accepted. Problem B. Given endpoints on the 2-dimensional plane, some coordinates, we want to the constraint allow us to iterate over all pairs. So I see no reason not to. Let me create quick template structure point. Needs not be template, but we can afford it, so. Yeah. And I would like to read it from the standard input as usual. So I will have instream and also point reference point. And I guess here we can have like instream goes to point X to point Y and return instream. This will allow me to use my template. So now we can do simple as this. Const auto points read array point it will first read the size of the array, and it will then read the vector of points. I guess we then do just what we are told. So int answer equals 0, cout answer. And then we want slope of the line. So let's create the corresponding function. It will return a long double. And let's actually pass by value, because I want to swap the points. If first x is greater than second x, then I want to swap the points. This way, okay, we can have also like vertical lines. Let's check against it. First x equals second x, and we can return like numeric limits long double max, whatever, right? Otherwise, we can return second y minus first y divided by a second x minus first x. That's the slope of a line. If slope points I points no, actually we want it like here, slope, right? From -1 less than or equal to slope, and slope less than equal to 1. Yeah, let's also do like this. Just then we can increment the answer. Let's check. When we only have like 1000 points, so we'll iterate through 1 million pairs around so. And I think we're happy with this. Okay. Something went wrong with declares non-template, right? You are absolutely correct. Point is a template, and we definitely want to reflect this in the declaration. Wow, it's really long. Yeah, next time around, we will have like a local compiler, I promise you, because this is just non-verbal. Hello, what takes so long? No, really, it's not okay. Oh, you mean that operator should be template as well? Okay. But I thought it is already, no? What exactly is wrong with that template? Do I have to simply write like this or what? I don't understand templates. But in theory, it should be like better, right? Right? We should not do this. We just stick to coordinates store. But then here we want something like that. I guess. Here we also don't have point t, but we have point. I don't understand. Do I have like to? I think I may like shade off the. Just prevents compilation. Yeah, whatever. We can live without it. Here we got 2. Here we got 0. Here we should get 11. That's correct. One set. Okay. Sounds kind of funny. Okay, accepted. We're given n strings consists of lowercase English with 0 or 1 bank added at the beginning. Okay. We said string t is to be unsatisfied if it matches one of regardless of whether we add at the beginning of t. I don't understand this statement. I think we can like add t and then check if it's add bank and then check if it is correct, if it's present in the set. Ah, okay. Yeah, now I understand. Like, okay. Actually, we can do like this. After strings, right? Read array string, I guess. But in fact, we would like to convert it to another set, I guess. Should we do like an ordered map instead? Let me think about it. Yeah, whatever. We have map of strings. So what will it do? What will it do? I guess it will go to integers, and we will discard like bank, right? Okay, but we can have like red multiple times, right? So let's have like pair of integers. It will first will denote the count without banks, second with banks. So if string 0 equals bank map string substring from first to the end 1 to plus plus second entry. Else we want to plus plus map at a string first entry, and we want to iterate through keys and values. If v first greater than 0 and v second greater than 0, then we can output key, and that's it. Otherwise, do we have, okay, otherwise we want to return satisfiable. Actually, not return, but yeah. Let's check if it works. So we basically like have an ordered map that counts like how many times string is present without a bank and with a bank. Yeah, obviously I did something wrong with this std move. Let's. I will also remove it like everyone. Yeah, I think I was rewriting this template from somewhere else and did something wrong. So, not a big deal. Okay, here we have D, which is kind of okay. We can print any. We can print any of unsatisfied string, and D is another option. Here we should say satisfiable. Okay. Where is our code? Let's go back to tasks. Choose me. Okay, I'm back. AtCoder city will hold a mayoral election. Very good. 2 candidates and towns. Some votes here, some votes there. Okay, to get more forwards. Okay, that's not particularly difficult. Let's create struct waters, or actually city. So in first waters, or actually bad waters, in good waters. Now you need to understand, like in real life, there are no bad waters and good waters. Like every water is good, right? Stream reference operator. Yeah, and again, I need the input operator for elements of the array for my template to work. Not particularly difficult to write. I guess we just go like that. Here we don't need anything. Int string goes to city bad waters first and to city good waters. Very good. So what we will do, we will sort these things, and also actually we don't need city ID, right? Auto cities or read array of city, it will automatically read the size first if you don't give any, and then it will read elements. That's it. I think we can sort cities. We will need a comparator, right? We actually want to, well, every time we make a speech, we get like AI words. So we want to we want bad watts to be decreasing, right? Just to make sure everything is correct, I will introduce complete order so that we know that we always can compare. I don't think that it breaks anything in standard sort. So I'm not sure. Okay, so we sorted cities now. Bad total. Yeah, we'll need total bad votes, total good votes. I guess we can like accumulate over all cities these votes. And here we'll need another lambda function like that. So what it will do, it takes, actually it will take, two cities, I think. It will take two cities. Or will it? No, it will take accumulator. It will also take a city. And then it's supposed to return another integer. It will return accumulator plus city bad waters. Right? And we can just compute good waters in the same fashion. So far, so good. While total bad greater than total good. Actually, do we want like to get strictly more, right? Yeah, strictly more. So while bad has at least good, and speech count get 0. And it's always possible, so we'll just output it here. Actually, we can iterate over cities. They are now sorted in decreasing number of bad votes. So total bad. We'll put it here. Like so. Then what do we then? Total bad gets minus city bad votes. Total good gets these votes, right? I think this is it. So we simply like transferring the most valuable cities first. Oh my, oh my. Did I mistype stream? Right, right, stream. Huh? 43.3. Right, so you're absolutely right. Here we want to return this value, of course. What is it? 82? 82? Right, because we want to return input stream. It's not necessarily because we are actually not like inputting several cities in one statement. Wait, this is bad. Oh, because we want to break on exactly the opposite condition. You are absolutely right. Okay, should get 1. Okay, we should get 3. No, we did not get 3. Actually, why did we not get 3? 2 is enough. Hello? Wait. If it makes pitches at 2 cities, he will get 6 and we will get 7. Excuse me? Ah, his voters will not vote. Whoa, okay. Okay. So we did everything wrong. Oh, not everything. Not everything. We want to sort on a number of how many we are actually gaining? Like we are gaining 2 times bad voters because they transfer from our key to us, and we also get our voters. So we want to sort based on this condition, and initially good count is 0. I think so. And we also get plus city good voters. Yeah, now it's correct. So idea was correct. We want to transfer more or less valuable cities first, but the notion of value is different. So here we now get 3. We should get 1, and also here as well 1. Okay. Let's take a look at the next problem while we're waiting for. Oh, wow. Okay. Can we have some details? Okay, so some test cases passed and some did not. Very interesting. Probably I think, yeah, right. Obviously, like total bad, total good have to be long integers. Yes. And I think that this is enough. Like we always add to some variable that is long already. Should be fine. And also in accumulator also. Well, here we may run into problems, so let's be careful as well. I don't think we broke anything like worse than it was. So. Yeah, that's correct. I mean, it was obviously stupid of me not writing long integers, but whatever. Okay, take a look at the next problem. Is it? No, it's still interesting. Is it any better? No, okay. Very interesting. Like, what actually went wrong? Oh, because this value it was not long whatsoever. Let's wait actually for this rounded. Okay, it's already better. Yes, okay. Well, I guess you can like simply write the long integers always, but yeah, we will do exactly that next time. Okay, in problem E, we are given a tree. Okay. Vertices have integer labels. Given queries, we want to do something. I'm not sure that they understand what's going on. we want to like increment everything that's reachable from first vertex no. We're given edges, right? And then we say like so I'm guessing that EI is the ID of edge, and we want like to increment everything like in the subtree of one end and one endpoint of this edge, not in the other. And if the second, then we do like the like inverse operation, basically. Oh, that's interesting. We have a lot of queries, we have a lot of vertices. There is no simple solution as such, as far as I understand. I mean, I guess we can do something like lowest common ancestor, right? But it doesn't sound right. I mean, it's a very massive jump in difficulty. I don't understand. Maybe like it's common for this AtCoder, but I don't feel like doing LCA is correct in this problem. Yeah, so we can like pick a root and arbitrarily. No, actually, no. Like, what are we going? Well, okay. Like, second operations can be yes, bad operations like that. The ones that don't go like in understandable subtree, right? They end up being subtracted from that subtree. Then we also have like some global variable. Yes, correct. I'm guessing that we can like what if we take our tree, we pick a root, for example, vertex 0, and for every vertex, when we get a query, we increment the second label or decrement the second label depending on which query type it is, and then we'll just do one DFS at the very end. Yes, correct. I think it is correct. We don't have to process, yeah, after processing all queries, we want to print integers, and offline is obviously easier than online processing of queries. Vertex count. Okay. Actually, I would like vector of vectors, so like that. Okay. Can we actually do like this with a pair? I'm not sure we can. I don't think we can. Yeah, let's just modify. So now we have our edges for. So we can do like that, right? Yeah, we would definitely like to decrement vertex IDs by 1. So we create our graph here. That's correct. Query count, I guess. Oh, okay. I will also need like, wait, what are the initial labels? Initially all labels are 0, okay. Actually, what is, okay, type, edge ID, delta, type, edge ID, delta. Or actually, no, like this graph is not correct. Not exactly correct. Like we would like to have what? We would like to have like parent for every vertex. We want to know which one is closer to the 0. Okay. So we will do this. Vertex count, initially all parents set to -1. And then we would like to run DFS in our graph from 0. Also run path parent here. Now DFS won't return anything. It will take into vertex graph as reference, and also int as reference parents. Okay. Also parents like denote whether vertex is visited already or not. Okay, so run to do like what for auto adjacent in a graph vertex if parent adjacent equals -1 and adjacent is not root, then want to parent adjacent equals vertex, and we want to DFS from adjacent graph. I guess it is as simple as it gets. So we'll start at 0. We go to all adjacent vertices. If they don't have an actual parent, then we'll do DFS from there. It's okay. Okay, now we have like what? In edge ID. If type equals 1, then we are interested in adding to like first subtree. have switches here. We have type equals 2. We will also have like if parent C, we want like endpoints of this edge, right? First, second will be endpoints. So we'll take like what? Edges, edge ID. If parent first equals second, it means that first is proper subtree, right? And we want to increment all in subtree. So we select plus, no, vertex label first plus equals delta. And we also need like total delta, okay? Because we like interchanging operations. Like instead of subtracting from something, instead of adding to some different weird subtree, we are adding always the rooted subtree and or subtracting rather. And we also need to fix the total delta so that we know what goes on. Okay. Here we have like vertex labels. At second, yeah, so first is not proper subtree, so at second we subtract delta and also total delta. Delta should be incremented by delta. More or less the same thing goes here, except that we want to interchange variables. Now we do another DFS, which will print vertex labels, actually correct labels, true labels of vertex count. We do another DFS from what, like 0, graph, final vertex labels. So this time, okay, this time we already have parents. So let's pass them as well, so that we always know that we don't want to go to parent. Okay. So we have like constant vector of parents, and we have like answers, right? We want to get through adjacent if parent of adjacent is not a vertex. No, actually, if parent of vertex is not adjacent, we don't want to go to parent. And we are okay if this is a root. No, actually we don't need it. We just compare that we don't go to parents, right? And we don't care that parent of 0 is -1. So here we just check that it's not 0. Okay, then we want like what? Oh, actually we want also like actual labels that we accumulated. And we want also current label. And it won't work this way, but it will work this way. So this is accumulator on the path from the root. We will add total data later, I guess. Yeah, okay, then for auto vector label, final labels, the vector label plus total delta like so, or actually like so. Okay. So now we want, what do we want here? In this case, we are interested in going there, but we would also like to say like, well, when we enter the label, the vertex, then current accumulator should get increased. When we go out, it should decrease. Parent adjacent, okay. Here we should, after we go there, we should set answer gets label, answer at vertex, of course. And otherwise, I feel like we can just do DFS here. With labels, answer label. Yeah, let's check if it makes any sense. Why do we have two buttons to copy, like here and like here? Something is not wrong, is not correct, because DFS. Actually, I don't know what is wrong. Which line it is? 37. Okay, 37 is where? Here. Adjacent graph. Okay, it should be lowercase. It's a variable name, not class now. Before edge count, did we do anything wrong? Yes, we did. Okay. Yeah, not a big deal. We still have 53 minutes left, so more than half. Too few arguments for DFS2. That's right, that's right. We also would like to pass like actual vector. Actually, why we have a vector here when we should have vertex? Okay, now how many params we have? 6. It appears to be correct. I didn't put the comma in. What a shame. I did not put comma here. Where exactly? Here. Okay. Understandable concern, sir. Not great, not great. So we went somewhere where we should not. I don't exactly understand where it could happen. This DFS fills parents. This initial parents are set to -1. Yeah, let's actually check, like, where does it fail? Does it fail at parent No, so it computes parents just fine. And does it fail here, or does it fail in the last DFS? Okay, so it fails while reading edge, while processing queries, apparently. Why would it though? I mean, we have type, we have edge ID. Oh, because edge IDs are from 1. That's right, that's right. Now it does not segfault, which is already a great improvement. Let's check if it works with last DFS. Okay, so first case labels are correct. Second case labels are correct. Third case, well, we have lots of labels here. I can hardly compare that many numbers like visually, but it appears to be correct. Now, I don't want to get into the same trouble. We will have in 6040 labels, obviously. In 40, no, in 6040. Also, total delta should be. Vertex labels are correct. This is correct. We also need like transfer labels here. Obviously, here we want 64. Yeah, we can. It's passed by default. So. Yeah, let's do the same thing, but add a bunch of zeros. How many zeros actually we can add like this? I guess all the answers should increment the same number of times, right? And it appears that they do. So we don't have like massive overflow despite this is clearly 3 billion should not fit like yeah, let me think whether or not we have any other concerns here, like parents can be integers, edges can be integers very well. Adjacency matrix can be vertex, parent, vertex. Yeah, looks like all labels, all that has to do with labels is one integer, which, yeah, let's just make sure nothing else like this. And with that, I think we can submit actually. A bit slow, It's okay. Oh, we can do like this, right? Very slow. What happens if I refresh the page? I also have one clarification. Oh, okay. Does it matter? What are my... Where I can check my submission? I don't understand. Is it here or is it where? Yeah, oh, my submissions, okay. Apparently it did not went through. Let's try it again. $25 out, okay. Is it like 31 correct or is it like 31 judged? Oh, okay. We got accepted on E. Now let's tackle the last problem. Given a simple undirected graph, two graph problems in a row. I'm not a big fan of that. Okay. Vertices, edges, again. I am seeing, okay, the input format is it different though? I mean, here we just have edges explicitly. Yeah, let's just copy graph reading. Obviously, we need a better template for this. But so far, we got what we got. Not sure that we... Minimum possible number of connected components in the graph after removing 0 or more edges so that the following condition was satisfied. Whoa, 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 relax. Relax. It's too much. So we basically want to remove some edges so that the result contains only clicks. But it's kind of a complicated problem, don't you think so? Hello? Are they okay with this? I mean, yeah, we're clearly, I bet there are like 100 of people who already solved everything. Yeah, I will just take a look at the leaderboard while I'm waiting. Okay, so obviously, like, you can't solve everything. How do we do it though? I mean, obviously constraints are very low, but also the task is quite hard. At least we already read the inputs, or did we? Read array h, not sure. Yeah, I should have just copy pasted from here. Obviously, we need also a better template for this because I can't define. Well, actually, I mean, if h was a structure, then I could define a friend operator. If it's a pair, then I don't think I can. We read input. What do we know next? So I have a bunch of actions we want to remove, like some of them should remain with clicks only. I think it's a sort of standard problems. They just don't know. Know the people around know. It says we know we want to remove some edges to remain with clicks on, so that's fully connected graphs. Oh, actually, we want to find the number of connected components, not the number of edges removed, which can be a bit easier. How do we find this number of connected components? Basically, what we're saying is if there's no direct edge between two vertices, then they have to end in different components. Yeah, I guess I'll need some paper and actually think. It's a good contest, and we have to think. Interesting. Also, we don't have many vertices. Okay. Okay, it's kind of trivial. I did not came to samples for trivial test cases. Yeah, it looks like it is correct. I expect to be next if this goes to one component, this goes to second, this goes to third, this goes to floors. Why actually? Did I miss any vertices? 1, 2, 3. Yes, 7. 7 is the original separate from everything. Oh man, this is hard. Yes, in case I can break and come back when I have a solution.